Today we're going to discuss coordinate planes. We talked about them a little bit during the last lesson because we talked about coordinate points, but today we're going to talk about coordinate planes and talk about what it looks like. Now, coordinate planes goes two ways. You have one arrow that's going this way and then one arrow that's going this way, and these two things here and here are called axes. They're called an axis. And you have one axis that goes up and down forever and ever. And then you have one axis that goes side to side forever and ever. And the first one is called the y-axis. The way I remember the y goes up and down is because I make my y look like this. And I draw two arrows at the end. And just to show, the y-axis goes vertically forever and ever. And the x-axis goes side to side forever and ever. Now, we talked about this ordered pairs on the last video. And a coordinate plane has what's called ordered pairs. And these are two numbers that tell you about the two axes. Now, which letter comes first in the alphabet for the ABCs? Well, the letter X comes first. So the first number is going to tell you the x-axis numbers. Remember, the x-axis is how far it goes over one way or the other. And the second number, that's going to tell you the y-axis. That tells you how far up it's going to go or how far down it's going to go. And what we're going to do is we are going to practice using these points. So we're going to focus on this table. And we are also going to practice plotting these points at the end. And then finally, we're going to come up with a rule that describes the x and y-axis numbers. So let's start by telling where these points are. Now, this point right here, to get there, you have to go over 1 and you have to go up 2. See how it's at the 1 on the x and a 2 at the y? So that means its ordered pairs are 1 because I had to go over 1 and up 2. This next point, you can tell it's farther over and it is farther up, and it is at 2 on the x-axis and 4, so 4 and 2, on the y-axis. And the last point we have, it goes over 3 and it goes up, my lines aren't perfectly straight, I'm sorry, but it goes up 6, so that means it's at 3, 6, and down here we have two more points that we have to plot, 4, 8, and 5, 10. The first number is going to tell me how far over to go, so over 4. The second number tells me how far up to go, so I'm going to go up to 8 once I see my line is up to an 8. And the last one's how you're actually really going to see it. You're not going to have the line that goes over and the line that goes up. You're just going to imagine that you're drawing a line from the origin. Origin's this number. The origin is whenever you are right where the two meet. That's at point 0, 0. When it ends up looking like eyes and a little nose. You don't have to draw that. But the 5, you're going to go over to 5 and you're going to go up to 10. So that point would be right, if I was to draw lines, that point would be right about here. And what you're probably noticing is that all of these, let's see if I can get an arrow that will work for this. It starts here at this point. It starts here at this point, and it makes a pretty straight line that goes on and on and on and on forever. And that would also tell us that if this was our next one at 6, it would be over here. Now, we have to figure out a rule that all of these numbers follow. And the way you could do that is actually making your own function table. Mine's a little bit crooked. I'll try to make it better. Slightly better. So we're going to have to find a function table make a function table for our x numbers and our y numbers. So we have 1, 2, 3, 4, 5 sets of numbers. So 1, 2, 3, 4, 5 sets of numbers. The first x and y ordered pair is 1, 2. My next one is 2, 4. My next one is 3, 6. My next one is 4, 8. My next one is 5, 10. So if we set this up like an in and out table, it goes in here, it comes out here, it goes in here, it comes out here, it comes in here, it goes in here and out here, in here, out here, in here, and out here. Can we figure out a rule that we can have in this box? I'm going to let you pause the video and see if you can figure out this one-step rule. Now that you're back, that means you're probably pretty close to done. And you have found that you can't add because 1 plus 1 is 2, but 2 plus 1 is not 4, so I can't add. So I'm actually going to have to, as numbers are getting bigger, I'm going to have to multiply. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. 5 times 2 is 10. So that means any x number I have, if I multiply it by 2, it would get me my y number. So that's my rule. And what we're going to do is we are going to combine what we learned yesterday, what we learned today, and we're going to have a function table with a coordinate plane on top of it, kind of. So let's combine what we've been talking about for the past couple days, a function table with a coordinate plane. So first one we got to figure out is we have a rule box down here. We got to figure out, well, what's my washing machine set to? If it comes in a 1, it goes out a 3. If it goes in a 2 and out a 5. If it goes in a 4, it goes out a 9. I want you to, if you're with a group, work with your group. If you're at home, I want you to figure out if you can figure out the rule. I'm going to tell you that it's actually a two-stepper. So it's going to have two operations you're doing. So pause the video and see if you can figure it out. Okay, now that you're back, that means you must have figured out the rule or you couldn't figure it out, which is okay. I'll go ahead and give you a little bit of a cheat sheet and say that my x is going to have to get multiplied by 2, and then I'm going to have to add the number 1. Because 1 times 2 is 2, 2 plus 1 is 3. 2 times 2 is 4, 4 plus 1 is 5. 3 times 2 is 6, 6 plus 1 is 7. And 4 times 2 is 8, 8 plus 1 is 9. So now that we have all of that, we need to combine our information right here and make our ordered pairs. We have all of our x numbers and we have all of our y numbers. So we need to make them ordered pairs. My first ordered pair is 1, 3. My next one is 2, 5. My next one is 3, 7. My next one is 4, 9. And all of this information, we are going to plot it over here. Now, I did purposefully leave the stuff blank on the x-axis down here at the bottom, because if there is nothing there at the bottom, there's no numbers, you can just assume that each line is worth 1. So 1, 1, 2, 3, 4, 5. It ends up kind of being like a number line. So my first ordered pair is over 1 and up to 3. My next ordered pair is over 2 and up to 5. I want you to pause the video and see if you can plot the other 2 points. Now, work with me, see if you got them right. So the next one is 3, and up to 7. And the last one, I'm not going to do the drag method. I'm just going to go to my x-axis, which is a 4, and go to my y-axis, which is a 9. So it would be somewhere right over here. And as you can tell, if we start right here, it pretty much makes a straight line that would go on and on and on forever and ever and ever. Now I know that my drawings aren't perfect, but we got it pretty close. Now this last one I want you to do completely independently. See if you can figure out the rule that goes in the box right here. See if you can make your ordered pairs. See if you can plot your ordered pairs and see what you get. So pause the video, then come back with me and see what you got. So before you can figure out where to plot the points, you have to figure out the rule. If I go from here to here, my numbers are getting smaller, here to here. And it looks like they're going down by 1 each time. So I believe that any of my x numbers, to figure out my y number, I would have to subtract it from 1, because 2 minus 1 is 1. 3 minus 1 is 2. 4 minus 1 is 3. 5 minus 1 is 4. So I figured out my rule. I have all of my blanks filled in, so now I need to write my ordered pairs. Remember, these are my x's up here. All of these are my x's. And all of the stuff down here are my y's. So I have 2, 1, 3, 2, 4, 3, 5, 4, 6, 5. My first one is over 2, up 1. My next one is over 3, up 2. My next one is over 4, up 3. My next one is over 5, up to 4. My last one is over 6, up to 5. And if you did it correctly and you have all your points pretty close, I know they're not going to be perfect, but you should be able to make a straight line from your first point all the way to your last point. And they should go on and on and on forever and ever and ever. So if you plotted all the points correctly, I want you to put a check next to your coordinate plane. If you found the rule, put a check. If you found the missing one, put a check. And if you got all the ordered pairs correct, put a check. The last page is actually, so everything over here is just a review of the concepts we've covered up to this point with no coordinate planes or function tables. There will be information on rounding. You will have to subtract with decimals. Don't forget to add the zeros. Add with decimals. Writing numeric expressions. Solving multiplication problems. And then solving order of operation problems.